So now we're going to look at 5-4. Now 5-4, we're not going to learn anything new in this section. It's just a matter of reviewing all of it and figuring out where to begin on these. So I'm going to pick them out in a random order just so we can get used to figuring out and counting the number of terms and trying to think about how we would factor something. So I'm just going to pick out some random questions out of 5-4 to look at. And I'm going to start on page 366. And let's see if we can remember how to factor question 7. Okay. And this is an example of something that's prime. Okay, where do I begin? Well, I count the number of terms. Now, the number of terms is going to tell me how to factor and what to do. I have 2 terms. When we have 2 terms, we try and use a special formula. Now, we have squares, we have cubes, but we only have a difference of squares. For the cubes, we have both a sum and a difference. So when I look at this one, it looks like, okay, it's p squared there. And you can always use a calculator to check for squares. 225, right, is a perfect square of 15. 256 is a perfect square of 16, right? So it is squares on those, but why is this one prime? Why can I not factor it down? Well, when we look at squares, we have only a difference of squares. This is a sum of squares. And sum of squares won't factor. Difference will, but sum of squares won't. So this is what's called prime. And why is it prime? Because it was a plus. Now, if that would have been a negative, if it would have been a difference, you could have factored it. But that one is a sum, so we can't. Okay, let's try something else to look at. And I'm mixing these all up in different orders. Let's see what we can do with question 25. I'm just mixing them up because that's how your homework is, and that's how, when you get to college algebra, they're going to be all mixed up together. R plus 4, 3r minus 1, and then we have, oops, sorry, that's going to be minus there, minus r plus 4 and r plus 2. Okay, now, where would we begin on this one? Well, whenever I come up to a question, the first thing I look at when it's factoring is I look and I see, is there anything in common here? Do we have a set of parentheses or some variables or numbers that are the same? Yeah, what's in common here? Look at your parentheses. What do we have in common? Okay, r plus 4, right? These are the same. So what's going to happen then is the r plus 4 is going to come out in front. And then we write what's left over. And so what's left over? Well, what's left over is 3r minus 1. That's gone and that's gone. Don't forget the minus needs to come down, so that minus comes down with it. And whenever you bring down that minus, you need parentheses. And if the r plus 4 is gone, what's left over? R plus 2. Now, how do we finish it out? You should see what to do from here. We got to distribute that negative through. And then finally, for our finished final answer, we can combine things together. So what can we combine together here? Well, out in front, we still have an r plus 4. What about inside here? We've got a 3r and a minus r. That leaves you with a 2r, right? those go together there. Or sorry, that goes together there. So 3r and a minus r leaves you with a 2r. And then we have a minus 1 and a minus 2. Well, that leaves you then with a minus 3. And that's how you would work out question 25. We've done all of these before. They're just all mixed up. Some are cubes, some are squares. Some might be a trinomial where you have to take the first times the last. Everything we've learned is just all mixed up together. And I'm trying to purposely mix these up to get us used to seeing them mixed up. Let's do another one. How about question 8? Okay, let's go back and look at question 8. So we've got 18, m cubed, n plus 3, n squared minus 6m n cubed. So, does anyone have any idea what I should do first? If you were looking at this question, what should you do first? No, yeah, we can't combine them, but we can factor something out, right? Okay. What can we factor out? Let's look at the numbers. What can come out for the numbers? What do these have in common? 3. Okay. So start with that 3, and then what else? They all have the variable m, right? Now, what do we factor out? They all have the variable m. We take out the what? Smallest power. So what's going to come out is a 3, an m, and they all also have a what? N in common. So the first thing I would do before I do anything else is I look at it and I say 18, 3, and 6 have a 3 in common. So that comes out. They also have an m, and they also have an n in common. So that's going to come out at the very, very beginning, and that's the first thing that you should do. Always start by seeing what's in common. You have to do that first. Now we see what's left over. So now we start dividing. 18 divided by 3. Well, 18 divided by 3, that leaves you with the 6. M cubed, we're taking 1 out, so that leaves you with an m squared. And the n is gone. Then we come to the middle. 3 is gone. M squared, take out an m, that leaves you with an m. N squared, take out an n, that leaves you with an n. So mn is left in the middle. And what's our last piece going to be? Well, 6 divided by 3, it's negative, so the negative is coming down. 6 divided by 3 is a 2. The m is gone. N, though, we've got 3 of them. Take 1 out, that leaves you with an n squared. All right, is everyone okay with that so far? So that's the first thing we did, was we factored out what was in common. Now, check for squares. Is 6 a perfect square? Nope. Is 2 a perfect square? No. If they were perfect squares, it might be a perfect square trinomial. But this one is not. So they are not squares. So what do? We take the first times the last. Why? Because we have 3 terms. 2, 3, right? 3 terms, what do? First times the last. And that is then a minus 18. What do we know? 1's positive, 1 is negative. Sign in the middle is positive. What 2 numbers are going to work here? Multiply together to give you 18. How did I get 18? Sorry about that. Should be 12. My mistake. Yep. Sorry about that. I was looking at, I don't know why I said 18. I was thinking of the 3. It should be a 12 there. My mistake. I was wondering why, and it wouldn't work anyway. So this one will work. So a 12 will work. So what 2 numbers? Well, we need 12, right? And we need a difference of what? 1 in the middle. So we've got 12. Okay, how about 3 and 4. Would that work?
Yeah.
Okay, so we need a positive 4 and a negative 3. And sorry about writing the 18 down first. That was my fault. I don't know why I wrote down the 18. I think I was thinking of the 18 up there. But 6 times 2 makes it 12. It's a negative. Now, we know we need a positive number in the middle. Okay? And we need two numbers that multiply together to give you a negative 12, which those do. And then 4 and 3. 4 minus 3, that gives you a 1. That's what we want. Now we split it up. And we've got 6m squared. We've got a 4mn, a minus 3mn, and a minus 2n squared. So just to kind of review, when we have 4 terms, what do we do? When we have our 4 terms, we try and rewrite them and split the middle. We try to rewrite that into 4 parts so we can factor by grouping. So 3 always makes it into 4. And first 2 pieces, what can I factor out? Can someone tell me? Yep, 2 and a m, right? Okay, and that's going to leave me then with the 3m and 2n. Next 2 pieces. It begins with a negative. So what am I going to factor out? Negative, and what else? N. Okay, if I factor in a negative n, that's going to switch my signs, and that's going to make it a 3m. That matches. Negative comes out. That leaves you with a positive 2. N squared. Take out an n. That leaves you with a 2n. That matches, doesn't it? They have to match. If they don't match, you made a mistake. These are now the same, which they should be. If they are not, you made a mistake. 3m plus 2n, gone, gone. What's left over? 2m minus n, and do not forget what's out in front of all of it is a 3mn. Let's try another one here. A little bit different on this one too. How about 37? See if we can remember how to approach question 37. $512 plus 1,000 z cubed. Now, how many terms do we have? 2. Okay? So, we are going to have to use a special formula. Before we ever work with the special formula, take that first number times the last number to split the middle up, always check to see if we can factor something out to begin with. Now, I know that something will probably come out because 512 and 1,000, those are both even numbers. And if they are both even numbers, at least a 2 will come out. But I think more than a 2 will come out. I think an 8 will, because we've got 512 and we've got 1,000. So let's see if we can, what we can do here. So 512, okay? We can do a 2, right? It's still even. We can do another 2. We can do another 2. So it looks like 8's going to go in there. And by the way, 64 is a perfect cube. What about 1,000? Does 8 go into 1,000? Yep. 125, and 125 is a perfect cube. If you didn't factor the 8 out at the beginning, it would still work, but you'll have to do it at the end. And it's usually easier to do it at the beginning than at the end. So the first thing I did was I looked at those numbers and I took out what was in common. The largest number in common is what you want. In this case, it's an 8. So that 8 came out. Now I knew I was on the right track because this is cubed, right? And these had better be cubed. And we know 64 is a cube. 125 is a cube. Use your table of cubes if you need to. So 64 is a perfect cube of 4. 125 z cubed is 5z, right? 5z and 5z. And how do we know it's a cube? This is cubed. 125 is cubed. That's a cube. And this is a sum of cubes, right? Two terms. Whenever we have two terms, you've got to use a formula, special formula. Let's review the signs. How do the signs go? Starts off with whatever sign is in the middle for cubes. So this is a plus, minus, plus. The 8 just simply comes down. And we've got our 4 gone. What's left over? 4 times 4, which is 16. And we have a 5z gone. What's left over? 5 times 5, which is 25, z squared. And what goes in the middle here? That's those two multiplied together. So that's 4 times 5z, which is 20z. So that's going to be our final finished answer on that. And whatever comes off the cube will never go any further. So you never have to worry about trying to factor out that trinomial anymore because it came off of a cube. Okay, let's see if we remember how to do one of these. How about 69? Let's see what we can do with question 69. Okay, well, how many terms do I have? 4. Okay, if I have 4 terms, then automatically I know that I'm going to have to factor by grouping. Now, it might be grouping 3 things together. It might be grouping 2 things together. But we are going to have to factor by grouping. I'm going to try to group the first 2 and the last 2 together because this 3 matches up with that 3. So I see there's 3's here. So we're just going to try and factor it the way it is. And we're going to try to group these 2 together. If I group those 2 together, then we'll take out an x to the 4th. And that's going to leave you with an x plus 3. Simple enough there. Now, we know we're on the right track because when we kind of look ahead, this matches up with that. The only difference is it begins with a negative. And whenever it begins with a negative, what do we factor out? Factor out a negative. Then that leaves you then with switching your signs, an x plus 3. And we can take a 1 out of there because remember, whenever we factor the net, we always take a 1 out. Notice that these x plus 3's are the same. Okay, so that's x plus 3. Gone and gone. And what's left over? X to the 4th minus 1. This is one of the questions where we may have to go further. So we got this factored out. We did everything correct. Everything is right. We are not, though, completely done. X plus 3, nothing is going to happen with that one. That one is done. But what about x to the 4th minus 1? Well, that, if we look at it, just what I got underlined there, that's a difference of squares, isn't it? Because 1's always a perfect square. And x to the 4th, we can split that up into x squared and x squared. So this is a difference of squares. So we're going to go ahead and factor this one as a difference of squares. And that's going to factor out, then, let me get the right color here. That's going to factor out as a difference of squares. And that's going to be x squared and x squared. And 1 is a perfect square of 1 and 1. We're still not completely done yet. We've got one more step. This is done. This one has a plus. We can't factor a sum of squares, right? But that one will go again because that is a difference of squares. So what's our final finished answer going to look like? Let's write it all out. So we've got an x plus 3. We've got an x squared plus 1, because that's a sum of squares. It won't factor. X squared minus 1 will factor, plus and minus, x and 1, x and 1. And that is our final, finished, fully factored answer. It can go no further than that. And some of these you have to factor, and then factor, and then factor again. Let's try another one. Let me pick out a different one here. Another simple one. How about 55? Let's try an easy one again. Question 55. Okay, well, where do I begin? Can someone tell me what I would do at the very beginning? Look at the numbers and tell me what to do. Okay, factor what can come out of there. Right, and I look at these because these are even numbers, so I'm going to start with 2. Now I might need to take out more, but I'm going to start with a 2. And a 2 is probably going to work because when I take a 2 out, that leaves you with a 25 p squared, right, for that first piece. And we already know that 25 is a perfect square, so I know I'm on the right track. What about that 162? Well, if I take a 2 out of that, see, then I get an 81, and 81 is also a perfect square, isn't it? So by taking that 2 out, now we can see this is a difference of squares. And 25p squared is 5p and 5p. And 81 is 9 and 9. So difference of squares, how does it go? Plus, minus. We already know that 25 is a perfect square of 5p and 5p. And we know that 81 is a perfect square of 9 and 9. How do we know we can stop? How do we know we're done? This is sometimes where students get confused as well. We know that we can stop because it's 5 a square or a cube. Nope. Nothing comes out of here. 5 is not a square. This is not squared. So that means we cannot go again. It is done. Let's see. Let me find another one to work out here. How about we look at, let's look at 16. If I gave you this problem, what do you see? Okay, nothing's the same. Nothing will come out. But what else do we always look for? We always look for squares and what? Cubes. Do we have any squares? Okay. Are the ends squared? Yep. Okay. So, the ends are squared. This is going to be a perfect square trinomial. Right? Why? Because the ends are squared. Okay. So, 4k squared. That's 2k and 2k. 49r squared. 7r and 7r. Sign in the middle. Positive comes down. And what goes in here? 2k, 7r. That's it. Right? Don't try to multiply that 4 times that 49. It would work eventually. But always when you come up to something, look for squares, look for cubes, and see if something will factor out. And then if none of those apply, then you look at it in a more holistic approach and count the number of terms and try to see, okay, I can probably look at it this way. Okay, let's look at, let's see. How about question number 44? And again, I'm just all mixing them up, trying to pick ones that are different from each other, because when you come to your homework, they're all going to be mixed up. So that's why I'm mixing them all up. Well, do we have any numbers in common? Nope, because that 14 messes with the others, doesn't it? So nothing's in common. Do we have a square? Well, we got one square, but is 14 a square to go with it? Nope. So we can't factor it like the last one, because 14 is not a square. If that would have been a 9, we might have been able to factor it as a perfect square trinomial, but if 14 doesn't work. Nothing comes out. How many terms do we have? 3. Okay, so we've already determined how we're going to approach this one. Nothing came out, no squares that we can really work with. So, how many terms do we have? 3. When we have 3 terms, what do? First times the last. Let me make sure I copied it down right. Yep, I did. Just want to make sure I didn't make a mistake when I copied it. So now we take our 14 times the negative 25, and that's going to be a minus 350. Seems like it's a large number, but think about what it ends in. What does 350 end in? 0. So what does that tell you it has to have in it? Either a 5 or a 10. So we're going to be able to get this one pretty quickly. What do we know about the signs? It's negative. What's in the middle? Negative. Larger numbers, negative. Smaller numbers, positive. Where would you begin? We need 2 numbers. Multiply together to give you 350. Subtract to give you 25. Yep. We want a negative 35 and a positive 10, right? That's going to work. Now, I was able to quickly do that. Why? Because it ended in a 0, right? Look for patterns. It's all about patterns, and it's just a puzzle, figuring out how to approach it and the most efficient way of working these out. Could have started with 5, so you could have done 5, but you'd quickly get to 10, and it would work. Now, what do? Split the middle. So 14x squared. We've got a minus 35xq, a positive 10xq, and a minus 25q q squared. Okay, what can come out of here? Well, we've got a 14 and a 35. I think they both have a 7 in common and an x. And that leaves with a 2x. And then 35 divided by 7, the negative comes down. It's going to make it a negative 5. Next two pieces, we can easily see these have a 5 in common. And we have a q in common. And I think I forgot the q there. Yep. Because it should be a minus 5q. So that 5q comes out, and that's going to then leave you with a 2x, matching. 25 divided by 5, that leaves you with that minus 5. And q squared, take out a q, that leaves you with the q. We know we're on the right track because these matched up. These are the same. So now we've got we've got 2x minus 5q and 7x plus 5q. And that's finished. Let's try one more. And then we'll look at some area problems and how to work with these geometric figures. So we're going to look here at question, which one did I say? I think I said, 64. Okay, so question 64. We've got z to the 4th power minus 9z squared plus 20. Does anything come out? Nope. Do we have anything in common? Nope. What are we going to do? First times the last. We'll take a break after this question. And then we'll come back and we'll look at those areas. And then we'll look at 5, 5. So let's do this question here. Then we'll take a short break because this one will take a little bit of time to go through. Not a lot, though, just a little bit. Nothing in common. We've got 3 terms. 3 terms require us to factor and split up the middle. So first times the last is a 20. Okay. And can someone tell me what the 2 numbers would be? You should know the 2 numbers by now. You should be able to figure them out. Okay, 5 and 4, what about the signs? Yep. Both negative. Why? Because this is positive and negative's in the middle. So you are correct. We need a minus 5 and a minus 4. Those go together to give you 20. Those add together to give you the negative 9. So now we've got z to the 4th. We've got a minus 5z squared. We've got a minus 4z squared. And we've got a 20. Okay. Looks like z squared comes out. And that leaves you with a z squared minus 5. Begins with a negative, so you've got to factor out a negative. And also a 4. So negative 4 comes out. That leaves you within a z squared minus 5. Now this one's going to require us to do one extra step after we're done. We can put these together. Okay, those are the same. So that z squared minus 5 can come out. And that's gone and gone. And what's left over? Z squared minus 4. Now, we are not completely done. A lot of times students stop here. But you always have to go to the end and check to make sure that we can't go any further. Because there might be a difference of squares hidden, or cubes, or you might be able to factor a number out. Well, 5 is not a perfect square. So that's not an issue at all with that one. But what about z squared minus 4? Well, 4 is a perfect square, isn't it? And it's a minus. So z squared minus 4 factors down one more step as a difference of squares. And z squared factors into z and z. And the 4 factors into 2 and 2. And that is as far as I could possibly go, right? 5 is not a perfect square, so it can't go any further. Had that been a 16, then I'd be able to factor it again, right? But it can't, because 5 is not a perfect square. So what did we do on that one? We split up the middle, we factored it, we got to our end part, and then we realized that z squared minus 4 can go again, because that's a difference of squares. So then we factor that as a difference of squares.